Good morning, children. We are continuing the extra problems of chapter 8 quadrilateral. Line segments joining the midpoints of M and N of parallel sides AB and DC respectively of a trapezium ABCD and is perpendicular to both the sides AB and DC. Prove that AD equal to BC. Means it is given that ABCD is a trapezium. If it is a trapezium means one pair of opposite side is parallel, and it is also given that midpoints are M and N. M is a midpoint of AB, N is a midpoint of DC, and it is drawn perpendicular to both the sides. Now we have to prove that the non-parallel sides, that is which are they, AD and BC, that is to be equal, we have to prove. So what is given in the question? AB parallel to DC. M is a midpoint means what we can write, AM equal to BM, and N is the midpoint means what we can write, DN equal to CN. Okay. Now angle M is perpendicular to AB, N is perpendicular to DC. That I am not writing. You can write that one, perpendiculars to both A and B. Okay. Next, to prove AD equal to BC. No construction because already it is joined in the figure, that is AN and a BN. Okay. Now we can see the proof. What is the first step? Means we have to take the two triangles AMN and BMN. Already we have marked here equal sides, that is AM equal to BN and DN equal to NC. We have already marked in the diagram. Angle M 90, angle N is also 90. Now you see that we are going to take a first part over which triangle? The triangle 1 and triangle 2, which are the AMN and BMN. So let us write that one in triangle AMN and triangle BMN. AM equal to BM because M is the midpoint, right? So we can write here given. AM equal to BN. Now what about angle M? Angle M equal to 90. That is also given. Now we got first side and the angle 90 degree. Now one more side means we need, that is MN. So MN equal to MN common. Therefore triangle AMN is congruent to, because M is having correspondence with M only, so the middle letter is M only. If M for M only, then N is only for correspondence with N. So N in place of N, it is N only. So what is the left letter now? B only. So A is having correspondence with the B, so triangle AMN congruent to triangle BMN. Now see the criteria, one angle only, two sides. See the sides, first side, then the second side. The angle is included. So which criteria it is? SAS. Now from this, what you can write? AN equal to BN. CPCT. Equation number 1. What is the AN? This side, which is not used for proving. First side and second side we have used for proving. What is the remaining side? AN and BN. That is the hypotenuse for this right triangle if you are considering. AN equal to BN by CPCT. Now what is left now? One more angle I want, which is that angle means ANM. Triangle ANM equal to triangle BNM. Again CPCT only, but for understanding purpose I have marked here angle 1 and angle 2. So here I can write a CPCT equation number 2, that means implies angle 1 equal to angle 2. Okay, now we got angle 1 equal to angle 2. Now by this result, you know that it is given the figure that angle N is 90 degree. So what about this angle? angle 3 and angle 4, if I mark, what is the value of that one? Suppose this angle is 30 degree and this is also 30 degree, because we got 1 and 2 are equal. If it is 30, this angle will be 3 will be 60 degree only. Similarly, if it is 1 is 30 means 2 is also 30 only by congruency, then again 4 is also 60 only. Got this point? Angle 1 and 2 are equal, but angle n equal to total angle equal to 90 degree. Therefore 3 and 4 are also equal. So what we should write here, angle 1 equal to 2, equation number 3. The same result, CPCT only. Angle 1 equal to 2 we got. Now angle MND, I'll take angle MND equal to 90 degree. Okay. Now angle 1 equal to angle 2 we got. So that means angle 1 plus 3 equal to 90. Similarly, this side, that is angle MNC is also 90 only. That means angle 2 plus 4 equal to 90. So this implies angle 1 plus 3 equal to angle 2 plus 4. Angle 1 and 2 are equal angles, so we can cancel. So that means angle 3 is equal to angle 4, equation number 4. We have proved that step also. Now we have to prove that AD equal to BC. So AD as one of the side we should take, and BC as one of the side we should take, and we should write the triangle. So we are taking the triangle, which one? Triangle ADN and triangle BCN. AN equal to BN, right? AN equal to BN we already proved in the CPCT. AN equal to BN we have already proved in the CPCT 1, equation number 1. So I'll write here proved in 1. Okay. Now the second one is angle 3 is equal to angle 4. I'll write angle 3 is equal to angle 4. Again proved in 4. So we got angle here and we have got AN here. That means the included angle. So DN we can go for naturally. So DN equal to CN. That is given. So triangle ADN is congruent to triangle BCN. See the order, angle 3 and angle 4, that means N is having N only correspondence, so BCN we can write. Now N is having correspondence with the N, means for D what is the correspondence? C. So we have written here. Now once again we check this result we have proved by the last CPCT. This is the first equal side. Now the second equal side, the angle is included. Again the criteria is same, SAS only. The last time also we have got SAS, now also we are getting SAS. Now what you can say about AD? AD equal to BC CPCT. Hence proved. So what is given in the question? M and R N are the midpoints. So AM equal to BM, DN equal to CN. AB is parallel to DC also because it's a trapezium. Angle M 90, angle N is also 90. Both are perpendicular. Now DMN is the common side. Now we are taking this triangle only, AMN and BMN. In that first side, then the second side included angle. So we got that triangle AMN congruent to triangle BMN SAS. By this result what we are getting? AN equal to BN. So CPCT question number 1. Again by CPCT angle 1 equal to 2. I explained with the example how angle 3 equal to 4. So if angle 1 equal to 2, we also know from the figure 1 plus 3 equal to 90, angle 2 plus 4 is also 90. That means angle 3 equal to angle 4. Now first CPCT we got AN equal to BN and angle 3 equal to angle 4. Now we have proved. Now these are the concept we are using here. Triangle ADN, that is the other triangle ADN and BN. See, we are using CPCT, that is AN equal to BN. 3 equal to 4, that is angle 3 equal to angle 4 proved in 4. Now DN equal to NC, that is given. Therefore triangle ADN congruent to triangle BCN SAS. By this what you can write, AD equal to BC CPCT. That means non-parallel side of this trapezium are equal. We have proved here. Next question, ABCD is a parallelogram. P is a point on AD such that AP equal to 1/3 AD and Q is a point on BC such that CQ equal to 1/3 of BC. Prove that AQCP is a parallelogram. So what is given in the question? ABCD is a parallelogram. That means two pair of opposite side is equal and a parallel. Okay. Now what is also given? AP. P is a point in such that AP equal to 1/3 of AD. CQ equal to 1/3 of BC. That means, see this figure, that AP is 1/3 of total length of AD and CQ 1/3 of total length of BC. That is given in the question. Now what is to be proved? To prove AQCP is a parallelogram. Okay, already given in the question. Now we can see the proof now. If it is a parallelogram, what we can say about AD and BC, opposite sides of the parallelogram are equal. That is BC equal to AD. So I'll write first step that AD equal to BC. And also what we can write, AD parallel to BC. What is the reason? Opposite sides of the parallelogram. Now AD equal to BC. Now half of equals are equal, always we have written. This time we are going to write, then 1/3 of AD is definitely equal to 1/3 of BC. So what it is? According to the question, 1/3 of AD means it is AP and 1/3 of BC means it is CQ. So we got AP equal to CQ. Now AD parallel to BC. Now AP is a part of AD only, right? So what we can write, AP parallel to CQ is a part of BC. So AP parallel to CQ implies here. Now here AP equal to CQ, we got AP parallel to CQ. So that means how many pair of opposite side is equal and parallel? One pair of opposite side is equal and parallel. In which quadrilateral now? AP AQCP. Either I have to say in this order AQCP or we have to say APCQ. So what is this reason I should write here? One pair of opposite sides is equal and parallel, then quadrilateral AQCP is a parallelogram, hence proved. Okay. What is given in the question? ABCD is a parallelogram. P is a point on AD such that it is 1/3 of AD. Q is a point on BC such that 1/3 of BC. Now we have to prove that AQCP is a parallelogram. So we know that since ABCD is a parallelogram, AD equal to BC, AD parallel to BC. That means 1/3 of AD equal to 1/3 of BC we can take. Usually half only we can take. This time the question is changed to 1/3. So 1/3 of AD means what is given in the question? It is AP. 1/3 of BC means it is CQ. Now what is the other concept here? Parallel. So AD parallel to BC means AP parallel to CQ. So now what we got, APCQ, if you consider, it's a quadrilateral because four sides are there. Now one pair of opposite side is equal and parallel. That is the concept here. Therefore the quadrilateral AQCP is a parallelogram. With this today's class I am winding up. Thank you.